When I say your phone is your phone, but your calls are my calls, I actually mean it. I'm sure today all of us use cell phones. In fact, it's the basic necessity of our life. Imagine one morning you wake up, you need to make an emergency call, you need to contact, and you're just not able to make calls. What do? You wonder, what's wrong with my network operator? All you do is call up the customer care to find out exactly what happened. To your shock, they tell you, so your balance is nil. And you're just wondering, I have never used my balance. I never called up anyone. So how come my balance is zero? And when you call them again to confirm and ask for your itemized billing, it actually says you made a call and you were charged for it. Guys, my name is Vidin and I'm from Matrix Shell. My colleagues will emphasize more on this.
Good evening, guys. Before getting into more technical, I would like to give you a small introduction on GSM. So let's have a look at how GSM works and let's understand the key components of 4 GSM networks. We have tried to make the whole of presentation as simple as possible for all to understand. And I would like to kindly request you all, if there's any question, please ask after the presentation. Now let's understand the abbreviations that we will be using in the whole of presentation for a better understanding. The first is the BTS, that's a base transceiver station that are cell phone towers that you see above all the buildings. The second is the BSC, that's a base station controller. It controls the BTS. Then comes MSC, it's a mobile switching center. VLR, visitor location register. HLR, home location register. AUC, that's authentication center for calls. IMSI, there's an international mobile subscriber entity that's very unique for each and every phone number, each and every SIM card. Then comes TeamC, temporary mobile subscriber identity. That's a temporary key that's provided by the network. Then comes IMEI, I'm sure you all know about IMEI. Then SGSN, serving GPRS serving node. GGSN, gateway GPRS serving node. MSISDN, that's mobile subscriber integrated services digital network number. That's your mobile phone number. Now, this is the basic GSM working. This is a call flow structure. Whenever the mobile is powered on, it firstly sends a request to connect to the network. And the second kind of request it could be if anybody tries to place a call. The third kind of request could be any other request related to GSM or anything else. Now, whenever any of this happens, mobile converts it to request as per GSM layers, then you transmit it to the air via UM protocol. The device that you see, the mobile phone, that's actually your mobile phone app, and it connects to the BTS via UM protocol. The BTS then accepts the request and it passes it to the BSC via ABIS protocol. The connection between the BTS and BSC is microwave, which operates on a gigahertz frequencies. The BSC then demodulates it and passes the actual application request to the MSC. BSC passes this information to MSC via ABIS protocol. Now let's see, if it's an outgoing call request, the MSC processes that call request and establishes the call between the MS and the remote party. When the mobile is powered on, it sends a fresh request to connect to the network. This request is called location updating request. If it's a location updating request, the MSC and VLR communicates with the HLR to get the SS subscribers info and authentication info using SS7 protocol. We will focus on each of these ahead, like everything, SS7 network, HLR, VLR, MSC, we'll discuss each and everything in the later stages. Now if it's any other request like GPRS request or anything else, then it redirects the request to the PCU. Now the PCU communicates with the SGSN using GB protocol and processes the request further. Now let's not get into the later stage because that's not a part of our demo. Now this is a small explanation on the internal basement processing of a GSM mobile phone. When you are actually between a call, this is what happens. When you're talking on the phone, your voice is taken by the microwave of your mobile phone. It is then sampled so as to convert it from analog to digital. It is then encoded using certain GSM speech codecs. These codecs are then modulated using GSM layers to be transmitted over the air. Then the frequency up conversion is done to transmit those signals on particular ARSCM. This is called uplink communication. This is when you transmit your voice from your phone to the tower. The same thing happens when the BTS is sending the voice from BTS from the tower to your mobile phone. The same conversion process is initiated in the reverse order. That is called downlink communication. Now there are some GSM core network elements. Those are called BTS, BSC, MSC, VLR, HLR, AUC. These are the core elements of the GSM networks. Now let's get into detail of each of these. BTS, Base Transceiver Station. It defines the operation to the BTS whenever mobile requires a channel or a time slot to communicate. It is allocated by BSC. It takes signal measurements from MS. MS means mobile, your mobile device, from time to time to perform handover if needed. Controls handover from BTS to BTS, except inter-BSC. BSC, Base Station Controller. It is the intelligence behind the BTS. It performs all the functions of the BTS. It commands the BTS what to perform, when to perform, and how to perform. It handles the allocation of radio channels. It distributes the radio channels to every GSM particular calls as and when needed and as much as needed. It receives the measures from the mobile phones, like location updating request. It receives the measurement from the mobile phone. It defines the area where it actually is. This helps, the BSC helps in locating the device. It also controls handover from BTS to BTS, except in BSC. Now protocols used by BSC are A protocol. It uses A protocol between BSC and MSC. It uses ABS protocol to connect between BTS to BSC. MSC, that's called Mobile Switching Center. The MSC is a primary service delivering node for GSM responsible for routing voice calls as well as SMS and any other services. The MSC sets up and receives the end-to-end encryption of the connection, handles mobility and handover requirements during the call, and takes care of charging, the real-time and also the prepaid account monitoring. It is the main software behind controlling all the mobile phones, their balance, their calls, routing the calls, handing over from one tower to another tower. The functions of MSC, as I told you, sorry, as you can see. Delivering calls to subscribers as they arrive based on information from the VLR, connecting outgoing calls to other mobile subscribers or the PS string, delivering SMSs from subscribers to short messaging service centers and vice versa, arranging handovers from BSC to BSC from one tower to another tower, carrying out handovers from this MSC to another, support supplementary services such as conference calls, call hold, call diverting, any other XYZ services is handled by MSC. It also generates the billing information. Now HLR, it's called Home Location Register. The HLR is a central database that contains details of each mobile phone subscriber that is authorized to use the GSM core network. One IMSI or one mobile phone number can be associated only with one HLR. The HLR stores the details of every SIM card issued by the mobile phone operator. Each SIM has a unique identity called an IMSI, which is the primary key to the HLR records. The HLR functions. The main function of the HLR is to manage the SIMs and phones to move around. It manages the mobility. It sends the subscriber data to a VLR or SGSM. It's a broker between the GMSC or SMSC and the subscriber's current VLR. Remove subscriber data from the previous VLR when a subscriber has roamed away from it. When a subscriber has moved from one VLR to another VLR, it removes the information from the old previous VLR. Now let's understand VLR. This is called Visitor Location Register. The VLR is a database of the subscribers who have roamed into the jurisdiction of the MSC which it serves. It is actually used when a person is on roaming, or it goes from one area to another area. Each base station in the network is served by exactly one VLR. Every base station has one single VLR. Hence, a subscriber cannot be present. One subscriber cannot be present in more than one VLR at any point of time. It can be only present in particular one VLR. It could be either HLR or it could be either VLR. The data stored in the VLR has either been received from the HLR, because the HLR is the main holder of the subscriber's information. So the VLR receives all the information from the HLR and then authenticates the phone. Or it collects information from the mobile phone itself when the mobile sends a request to perform any request. Now, VLR data includes IMSI, the subscriber's identity number that it receives from the HLR, authentication data. There are certain authentication norms to be followed when you are making a call. It actually processes within the system. MSISG and the subscriber's phone number. GSM services that a subscriber is allowed to access. The VLR knows exactly what services a subscriber is allowed for. It access points GPRS if we subscribe. The HLR address of the subscriber. The HLR is the main address of the mobile phone number. The authentication center. The AUC is a function to authenticate each SIM card that attempts to connect to the GSM core network, normally when the phone is powered on. Once the authentication is successful, the HLR is then allowed to manage the SIM and the services. The AUC does not engage directly in the authentication process, but instead generates data known as triplets for the MSC to use during the process. Now, we understand the whole process of triplets and the authentication in the later stages, because that's too hardcore technical, and that's where we are going to target, and that's how we are going to do the main demo. The AUC is the main thing because it actually authenticates the caller, it authenticates the subscriber to the base server. Now, the AUC stores certain keys. The first is the KI. It's a key for authentication. It's stored in the SIM card. Again, it's very unique with each and every single SIM card. Algorithm ID. The standard algorithms are called A3 or A8, but an operator may choose a proprietary one. There are certain algorithms that are being processed to generate a unique ID key for the authentication processes. These are called A3 and A8. Again, we'll study that in further. Now, the functions implemented by AUC are: it generates a random number known as RAND. It also creates a signed response key that is called SRES that uses A3 algorithm and using KI key that's stored in the SIM card. And it also creates session key called KC. It's done by A8 algorithm, again with the help of KI stored in the SIM card and the random number RAND. This KC is used for call encryption. The numbers RAND, SRES, KC from the triplet are sent back to the MSC. Now, this is called location updating procedure. This is where actually the main thing happens. This is where we are going to target. So I would kindly request my friend Akif Sayyed to continue with this and explain you all in detail. Thank you.
First, let's start with how the location update procedure happens. And the location update procedure is a procedure when your cell phone is turned on. First, it tells your BTS or your operator that yes, I am here. Please allow me to restore your network. So what it does is it first starts the location updating procedure using its previous LAI, its location identity, and its previous TIMC and its IMC. First it sends the TIMC and then the network asks for the authentication, or it first asks for the IMC, it's the International Mobile Subscriber Identity. And after that, after getting the subscriber identity, VLR requires the data, like give me the details of this particular IMC. Then the HLR will ask the AUC that send me the triplets for this guy, for this particular IMC. The triplets are the RAND. It's a random challenge, authentication challenge. Secondly is RAND will be there, and RAND and other three like it's KC and it's KC and SRES will be there. SRES is calculated with the help of A3 algorithm and KC is calculated with the help of A8 algorithm. Then this all information will be sent to the VLR, back to the VLR. Then after that, MSC will take this info from the VLR, from the VLR, and then will pass only the random access challenge to the MS. Then the MS will compute the SRES again and will send it back to the MSC. Then MSC will verify the SRES stored in the BLR or SRES in the which is computed by the HLR, and will compare with the SRES generated by the MS. If both matches, then the location updation is successful. During this process is called as a authentication, just sending the random challenge and computing the SRES. So, and if everything is okay, then HLR update happens. In that, it is tell to the HLR that yes, this guy is authenticated, please update his current location, current sale ID, and whatever. And team C is allocated to this guy. So let's have a look at the call setup, how the call is actually initiated. Whenever MS want to place a call, I'll explain this code diagram first. MS1 is calling through MS1 provider, and after that, the MS2 provider, there is a direct connection between that. I'm not explaining that part because we are more interested in how the MS1 communicates with his provider, and MS2 how the MS2 receives the call from his provider. So MS1 will tell him that I need a channel. Please give me the channel. Then it will tell him that yes, I have given you a channel. It will be the AGCH or immediate assignment channel, you can say. Then after getting immediate assignment, it will send that CM service request message. Okay, and in that it will specify team C, and after specifying the team C, it will see if the team C is correct or if the team C is there in the database, then only CM service accept will be there. If the team C is not there in the database, then at that time it will again initiate the authentication procedure, and it will again ask for the authentication. If the authentication is successful, then only that person or that particular SIM card will get the service. Else the SIM card, it will get that the SIM card is not registered or something else, or authentication reject message. Then after receiving the CM service accept message, the mobile will initiate setup command or setup message. In that it will specify the MSISDN or mobile number of the callee part to whom we want to call, and then he said that call procedure is going on. And in between the inter-provider communication happens, then how the next phone, the mobile 2 gets the call. Then first the guy will check, the provider 2 will check whether this guy is there in my line, whether it's switched on or not. If it is switched off, it will say that the XYZ cell phone is switched off. Else it will send a paging request. If the mobile is on, it will send a paging request. First it will send a team C paging request. If the team Z is matched by the particular XYZ, that particular cell phone, then it will say yes, I am there, please assign me channel, and then it will say that yes, I am there. If the team C response didn't come in specific time, then it will send the MC. It will say that please respond to this MC. If this MC response, you don't get the MC response, then it will say that this XYZ cell phone is not reachable. This is when you remove the SIM card, you directly remove, don't switch off the phone, just remove the battery, remove the SIM card and keep it for 2 to 3 minutes and call that number. It will say that this XYZ cell phone is not reachable. This is actually what happened. First it will page via team C, and secondly it will page via MC. If the response didn't come, it will say that this XYZ person is not reachable. So let's go for the next one. After paging request is completed, it will say that please assign me channel. MS2 will say that please assign me channel. And after assigning your channel to immediate assignment, then the paging response will be sent. Then it will say that you have a call. You should answer the call. Then setup will be there. Setup command will be sent by the network to MS. Here MS2 network is there in the first scenario. So then it will say that yes, call is confirmed. Then alerting, then connect, and the connection acknowledgement. Then the both mobile phone. Then same message happens here in sync way sort of. Once that response, here the message is passed. So this way the whole communication establishes, and this is how the call is completed. Now what we want to show, we are going to use someone's identity. We are going to use someone's identity to make a call. It means, let's take an example, if I have a Vodafone card and any other network card, not another particular card, so any other network card, I'm going to take his identity and I'm going to make a call. And balance will be deducted from that guy's account. I won't be paid. I'm not using the cell phone, any SIM card in my cell phone in my complete setup. So what we are doing here is we are using victim victim MC and fetching the TMSI. So that call will be placed on the basis of MC. Next, and the second will be the authentication bypass. We are bypassing the SRES and the RAN method. It's actually one loophole in the configuration of the network. It's not a loophole in the GSM, it's a loophole in the configuration. So tools we are using is the OSMOCOM and the OpenBTS. What is OSMOCOM? OSMOCOM is a baseband firmware for the TI Calypso chipset. TI Calypso, it means it's a complete chipset for the Motorola C123 series phone, and it's been used in 2006. Those phones were out in 2006 to 7. Now those phones are totally outdated. I have some phones here actually. I'll show them later. So we have this firmware. It is developed by the Mr. Harold Verte and his team, a complete Osmocom community. So what this Osmocom project is all about? So it is a project which uses a complete baseband chip functionality, and it allows you to do anything using that chip. You can either snip the network, you can collect the data from the network, you can do whatever you want, but only related to GSM part and GSM basic functionality of the chip. So, and the second is OpenBTS we are using. It's a SIP to UM gateway. UM, as my colleague said, debate that UM is the interface between the mobile station and the BTS. Okay. So, what is OpenBTS is? OpenBTS actually allow you to run your own GSM network, which I have here. This is the OpenBTS. Actually, this is a USR, is the software radio SDR is that, and all part is running on my laptop. I'll show you in detail. So, let's see what is OpenBTS setup here. So first I have my host PC. On that I'll install the Asterisk. Anybody familiar with the Asterisk? Many of you are. So Asterisk is a sort of VoIP PBX which we are using as a SIP communicator or SIP gateway, so you can say. OpenBTS and GNU Radio. GNU Radio is an open source software for processing, signal processing, and GNU Radio is communicating with the USRP, and OpenBTS is communicating with the GNU Radio to USRP with the help of GNU Radio. And whenever a calls are placed, the mobile will send the request, will search for the network, blah 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 blah, and then after searching the network, it will say that yes, I got a network. Yeah, you can, if you want to, guys, you must have searched the network, and you can see that there's a network named Matchshell is there. There are a couple of people registered. There are 22 people registered on my network, but I cleared them off. So what happens here is whenever you register a network, register a phone, and it properly works as a computer GSM base station, and then all the calls are converted to the Asterisk or to the SIP one. So what happens here is that you don't need a BSC, you don't need a MSC. The whole part MSC and BSC is completely terminated. So let's go for the next one. What is the Osmocom setup here is? See, here I have a Osmocom setup. Actually, this antenna USRP part is not there. This is the half part is a USRP OpenBTS and half part is a Osmocom. So GSM, I have cell phone. This is my cell phone. This one is there. I connected through the serial cable to my computer. Then this phone is communicating with the Osmocom firmware, and then the layer 1 is layer 1 or UM layer is processed in the cell phone itself. Then the layer 2, layer 3, and mobile app is there. In layer 2 communicates with the layer 3 and mobile app. Mobile app and the layer 3 are the same, but just for the understanding, I've placed it made them as a different. So let's have a complete look of please tell the number, please.
880.
Right.
656.
Okay, now let's try with the real network. I'm keeping my cell phone here.
उसी नंबर से कॉल करेंगे नहीं हाँ उसको उसी नंबर से कॉल करेंगे अपने
Call is proceeding and you got a thing, right? And cell phone is right here. I didn't use this SIM card, nothing at the number. I'll take his identity and make a call, and balance will be deducted from this account. If you want, you can check it. This is right. If you can even pick up the call, I can even talk from here.
Call is answered.
Actually, mobile is getting disturbances. I'll take this from here. Can you hear me? Where I incoming call. Okay, I'll make a call again. It's actually I'm not using a cell phone here. Wait. Yeah, you got a call? Yeah, you got a call.
You got a call from your number.
Check your balance.
Okay, if he answers, your balance will actually get deducted.
Yeah, you can. No, there's no way you can speak it there. I'm receiving call here. I can receive call from here.
Can you talk?
Yeah, I can talk from here. What you can listen there. Hello. Hello.
Yeah.
So if I want, I can
hear you.
So let's hang up.
Just check your balance. It was 610.47, right?
Now check your balance.
Now what's the balance? 609.47.
This can be happened with a network. This can happen.